Hey, howdy. Hey, folks. It is Mrs. Johnson. It's been almost a week and a half, maybe two, since I last uploaded something because my life is wonderful and amazing and full of adventure, and my schedule changed, and all sorts of things happened last week. And I did not get a chance to upload a video because I'm currently recording videos as I upload them. So, oops. Um, was gonna do grammar stuff, elected not to do that today because I didn't feel like talking about grammar. Instead, we were talking about completely randomized block design. This is a little off topic, I guess, a little more in depth than what some of this channel has talked about already, and I will fill in the gaps. Because completely randomized block design is a science thing. It is specifically a science experiment thing for agriculture. So let's talk about it. First and foremost, we're going to define CRBD, completely randomized block design. And then we're going to compare CRBD to CRD. CRD is completely randomized design. I might do a video specifically on completely randomized design. I might not. And then we'll talk about how to run completely randomized block design in Excel. We also haven't done Excel lessons in this class or on my YouTube, or really any science experiment setup lessons. So I'll have to come in and fill in the gaps there, but I will at some point eventually, is the hope. So what exactly is completely randomized block design? It is an experimental design that uses smaller blockings based on external factors, other factors than what you're studying in the experiment. And your treatment, which is the thing that you change in your experiment, will occur in every blocking that you do. We use this specifically in agriculture to ensure that variables aren't the desired measurement that we're accounting for, that the variables that we can't control or that we're not looking to research don't affect the thing that we're measuring. This reduces environmental variability and experimental error. Those are fancy science words. Experimental variability, just how across the board is my data. Experimental error is related to environmental variability. Um, like essentially how much of that across the board is my data is due to the way the experiment is set up. So let's talk about blocking. How do we block things, specifically in agriculture, right? First, we want to identify the intended and the unintended factors of the experiment that we're doing. And then from there, we want to block by unintended factors and then assign treatment types. That sounds a little confusing. Let's talk about it. In this first example on the top, right, if we want to identify right, the first example, that flowchart starts with crops. It says crops. It's got rice, corn, and wheat. That's a factor that we talk about. But then we also have F1, F2, and F for rice, corn, and wheat. What that means specifically is presumably fertilizer. So fertilizer amount 1, fertilizer amount 2, no fertilizer. And so, depending, right, then you would block by unintended factors first. So, in this case, crops, rice, corn, and wheat are the unintended factors. Those are things that we're not trying to study, but they're important to agriculture to know. Rice, corn, and wheat are fairly big commodities in the world. I wouldn't necessarily say the biggest or the largest, but they are fairly prevalent. They're in a lot of people's diets. And then assign treatments by the intended factors. In this case, our second layer of that flowchart, F1, F2, and F, fertilizer amounts, is the intended factor that we're trying to study. And then you take all that data from all that blocking and you analyze it. Analyze all the results, and you do fancy Excel things and all the things, which we will learn at some point. And hopefully I will backtrack and teach you about this because this is fairly in depth and a little confusing to start out with, but it's okay. We'll backtrack. YouTube is great. So that bottom picture, right? Block 1, block 2, block 3, T1, T2, T3. So B1, blocking. We've decided that we're blocking by crops, rice, corn, wheat. So we would assign each block a crop, right? So block 1 might be rice, block 2 might be corn, block 3 might be wheat, right? Down here. And this is what our like field map would look like. This is how we would lay it out in the field or in the greenhouse so we know who gets what crop gets what type of fertilizer. So T1, T1, T2, T3 stands for treatment 1, treatment 2, treatment 3. In this case, F1, F2, and F. The repetition of those numbers might be a little confusing, but you can see in each of those blocks, they're randomly assigned. So block 1, right? T, T1, T2, T3. Block 2 reads T3, T2, T1. Block 3, T2, T3, T1. So they're all different, which is what you want when you block. You want to isolate the unintended factors and set them by themselves and then randomly assigned within those factors. Now that we've kind of identified that, what is exactly the difference between completely randomized block design and completely random design? Well, completely randomized block design places treatments into blocks prior to randomization. So, in completely randomized design, just throws treatments wherever that randomization occurs. Like throughout the whole field, everything is 100% randomized. And it's all the same, right? Ideally, it's all the same. And so the top one, right? We have it blocked off into 3 sections. And 1, 2, 3, and 4 happen 3 times in each of the 3 times, 1 in each of the sections. That is completely randomized block design. Completely randomized block design like isolates the other factors, whereas completely randomized design does not take other factors into account. Completely random design is most useful for very small greenhouse experiments or very highly controlled environments. Specifically greenhouse experiments or like cellular experiments maybe, DNA experiments maybe, like something on a really small, really micromanageable level. So, completely randomized block design in Excel. How do we do that? Let's talk about it. Now, do excuse my buffering. It's been a while since I've looked at this. I jumped into this tonight without reviewing anything, so be prepared. And so we've taken that 3-block design with 4 treatments, the S1, S2, S3, S4, and we're using that as our example. Before we jump into Excel, let's talk about our statistical equations, right? For completely randomized block design, we're going to talk about treatment, blocks, errors, and your totals. Those are the source lines here. For each of those, mostly each of those, will have a DF an SS, an MS, and an F, right? T -1, treatment -1, SST, MST, FRT. These are all things that we can Google and look up at some point, and I should make a video elaborating on those. But they're here for your knowledge, for your information. You know what we learned? We learned completely randomized block design, definition, and uses, and its difference to completely or completely randomized design. That's supposed to be an R, not a B. I don't proofread my stuff, apparently. And we talked a little bit about experimental design in Excel and what that looks like. We did not do any analysis in Excel. Look at me not updating any of my slides. But, oh, that's my last slide. We did learn some things. That might be a little too advanced for this channel currently, but we're gonna leave it up, and the worst we can do is remake this video later. Thank you so much for learning on a very niche, in-depth topic. That might be a little hard to comprehend currently, but I will work on getting more videos up that talk more about the science things, because science things are super fun for me to talk about. And a lot of the basic concepts are also super fun for me to talk about. So without further ado, have a lovely day. Thank you for learning with me, and we will see you soon.